Welcome to Honors Geometry Lesson 11.2, the areas of trapezoids, rhombuses, and kites. All of these formulas are actually based on finding the area of a triangle. So let's get right at it. Area of a trapezoid. The area of a trapezoid is 1/2 the height times the sum of the bases. 1/2 times the height times the quantity base 1 plus base 2. How is that based on the area of two triangles? Well, what's going on here is take your magic scissors and cut along this diagonal right here. Actually, you could cut against that diagonal, but let's cut against this diagonal. Okay? Flip that triangle over there, so base 1 sitting over here, and I guess you don't really need to write this down, you just need to understand what's going on. The area of this triangle is 1/2 base 1 times the height. Its height is the same as that triangle, plus the area of this triangle, which is 1/2 base sub 2 plus the height. Okay, 1/2 and h are factors in both of these terms, so you could factor those outside, and what's left in parentheses are b1 plus b2. So really, this formula right here is nothing more than two triangles added together. Alright, let's put it into practice. Here's a trapezoid. Okay, the height is 4, right? The bases are 7, 9, so the area equals 1/2 times 4 times 7 plus 9, that quantity. Multiply that out, you get 32 square feet. And that's how you find the area of a trapezoid. Alright, so let's go ahead and move along to the area of a rhombus. The area of a rhombus is 1/2 times the product of the diagonals. So if this diagonal right here is diagonal 1, and the vertical diagonal is diagonal 2. Remember that a rhombus is a parallelogram, so the diagonals bisect each other. So we're going to talk about this red triangle up here and this green triangle down here. Okay, you don't need to write this down, just pay attention to see where the formula is coming from. Alright? So, the area of the red triangle, the base is diagonal 1. Area of a triangle is 1/2 base times height, so 1/2, the base is diagonal 1. And the height of this red triangle is 1/2 of diagonal 2. Green triangle. The base is, so 1/2, the base is diagonal 1 again. And the height of that triangle is 1/2 diagonal 2. So multiply the 1/2 times 1/2, 1/4 diagonal 1 times diagonal 2 plus another 1/4 diagonal 1 times diagonal 2. 1/4 plus 1/4, 1/2 diagonal 1 times diagonal 2. That's where that formula comes from. Oh, let's now go ahead and put that into practice. Now, sometimes they're going to show you that the length of the whole diagonal is like this, and they'll go like that to show you that that diagonal is that long and this diagonal is that long. They're going to do that sometimes. Other times they are going to instead do something like this and show you that half of this, whoops, I did that wrong, half is 18 and half is 12, so that you go ahead and, you know, so the area equals 1/2 times 36 times 24. 18 and 18 is 36. 12 and 12 is 24. So the area is 432 square meters. So 1/2 times diagonal 1 times diagonal 2. Let's look at the area of a kite. Through the same process with a little bit more difficulty, you can show that the product of the area of a kite is 1/2 diagonal 1 times diagonal 2. This is just one more reason in the growing list why I keep on insisting that a kite is a rhombus wannabe. It has the same area formula. Okay, this time you're told what the diagonals are in length, so the area equals 1/2 times 6 times 2. The area is 6 units squared. This does conclude Honors Geometry Lesson 11.2, the areas of a trapezoid, a rhombus, and a kite.